Welcome to episode number 508 of this here electronic engineering podcast called Amelia's Weekly Fish Fry, brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. How many always on systems do you have in your house? At least a couple, right? Funny thing, my son's name is Alex, and our Echo Dot is constantly getting his name mixed up with hers. Yes, my friends, Always On is the name of the game of this week's podcast. My guest is Amol Borkar from Cadence Design Systems, and we're talking about the evolution of Always On, the role that AI and sensors are playing in the trajectory of Always On device development, and the requirements needed for the next generation of Always On devices. So, without further ado, please welcome Amol to Fish Fry. Hi, Amol. Thank you so much for joining me.
Thank you. I appreciate the opportunity. Nice to finally be here on Fish Fry.
Thank you. So, we're talking about Always On today, which has been around for a long time with keyword spotting and similar capabilities. While audio and speech have been the focus, we're now seeing Always On using other sensors like cameras, ultrasonics, etc., right?
Yes, absolutely. Yeah, so to elaborate on that, audio-based always-on systems have been around for quite a while. There have been a lot of successful products as well that are in the market. In fact, a lot of our hi-fi DSP IP has been used in many of these shipping products, been very successful over the years. But as you can imagine, as the technology has been evolving, the market is now looking to do something more. So the natural progression, typically as you see audio and speech type of processing, and then the progression is to using images and video. So now having a video or an image-based always-on wake-up system is starting to hit the market. So to elaborate further on that, you have from an audio always-on system with the VAD, which is called voice activity detector, followed by keyword spotting or the voice word, which is basically the system is looking around to pick up those couple of keywords that a person may have spoken. So the equivalent of that is being used in these vision systems is, as you can imagine, visual wake word. So the idea here is instead of picking up a speech-based signal for words, here the camera is looking for keywords in the form of images. So here you look for possibly a person or a face, which is usually part of our human presence detection systems. So identifying, just if there is a person present in the scene, may not be going to the level of really identifying or recognize a person, but just is there a person, yes or no to that level. And this is effectively being done right now using the image sensors and AI. And just to go further, another step on that, typically when we say image sensors, the way the market is going and the way the commercial industry is, the first idea that most people get when you say image sensors is this image sensor going to be running at 4K or an 8K resolution, 120 frames per second or something like that? No, absolutely not. The image sensor itself might be capable of running that resolution, but typically in these always-on systems, they run in a sort of like a low power or maybe in an ultra low power mode where they're processing just maybe like 100 by 100 pixel window. This could be done with some type of region of interest or ROI type of processing on the image sensor, which could be sufficient to understand if somebody is present in the proximity or in the field of view of the image sensor. It could be running at a very low frames per second, about 3 or 5 frames per second, and don't have to go through all the fancy image processing and image cleanup, which is typically done by the ISP, the image signal processor, which does things like white balance, the gain correction, black levels, all of that stuff. This is usually a very basic raw or otherwise called bare image coming directly out of the sensor. And then basically the AI is just working on that. And from that regard, once you have that level of an image, very low resolution, very raw image, it's just standard AI that is running on there. But the subtle difference being you're running very, very lightweight AI networks. So, if you're talking about, give some type of an example, typically a network that is used to do image classification, like you've probably heard of it very commonly, called ResNet 50, very common network that is used to do image classification. It has about 100 layers as part of its topology. Well, when you're running in an always on system, a similar network used for image classification has about 10 or 12 layers. So you can see that the output is at a high level more or less the same. It gives you some type of a classification, but the complexity of the network is very small because these networks are just meant to run on very lightweight, very low power, efficient devices like microcontrollers. But generally, microcontrollers by themselves are not very good at just running AI. So having this sort of microcontroller type of a product with some additional AI capabilities is where this trend is going. And that's how this vision type of wake up, always on systems are coming into play.
That makes sense. Now, Amol, why do you think this is significant? What can this new type of system do that current audio always on solutions can't?
It's a very good question. So let me walk you through a simple scenario. So I'm sure you're very familiar with many of those home assistant devices, right? You usually call out their name like, "Hey, device," and it wakes up, right? So there is some type of always on audio processing, keyword processing going on over there. And now if you have some amount of noise in there also, these systems are usually quite sophisticated: beamforming, automatic noise reduction, echo cancellation, and all of that stuff. You can usually eliminate a lot of noise. But now just imagine, you have a big family at home and everybody's talking, somebody's playing Xbox, somebody's doing this, a kid is in the kitchen playing with the pots and utensils. Then even these devices have a hard time isolating what is sound and what is actually being spoken. So you can assume that, like in this type of a case, the audio or the microphone system could be quite possibly saturated. So where the trend is going is like, okay, let me put a camera on these assistant type of devices and maybe use some camera based wake up type of an approach as well. So you can imagine if the audio side is saturated or the microphone is saturated, you could use a camera to know if a person is nearby the system, right? Like if somebody is very far away, somebody walks nearby, or if there are multiple people, the device can subsequently wake up. And this would be a problem if it was purely just a voice or a speech-based system. Another example is now conference room systems are also trying to take this approach, because you can imagine right now in many offices to conserve power and energy, they turn off the lights in all the conference rooms, right? And they usually have either motion detector based lights that come on, or otherwise, the way these conference room systems are getting augmented is having this vision type of a wake up system, because many of these conference room systems typically have a camera that allow for a much better collaboration, more interactive user experience. So these cameras can basically be watching the room, again, in a very low power mode. And when somebody walks into the room, they can power up and be ready to get into conference mode. So in that case, most of the time they're conserving power and energy, and they wake up only when somebody walks into the room. Now, if you didn't have the vision system over there, you could imagine that somebody would probably have to come into the conference room and say, "Hey, system," or "Hey, something," and then the system would wake up. But that seems sort of unusual for a professional setting, that you have to say something to wake up the conference system. So this is where we are seeing some of our customers also trying to implement the vision always on capabilities. And many of our low power IP, like the Tensilica Vision P1 or some of our hi-fi family of products, are very well equipped to do just this type of solution.
So Amol, how are customers integrating these video always on solutions?
So there are a couple of ways to look at this. You can think about one category is the incumbent customers who already have perhaps an audio always on system, and they're saying like, okay, this is my next gen of product. I want to put a video always on system in there. So I need to add a video processing pipeline. And what they're doing is saying, okay, I have a system that's already doing the audio always on processing. Maybe I can just feed in the video processing to the same processor or to the same IP. Granted, it may not be very efficient, but it may solve the problem if the workload that the system is targeting is just something simple like waking up a device. We're not talking about doing full out face detection, face recognition, landmarks, and face tracking or anything like that. It could just be enough to say, is there a person or is there a face present? So the advantage of this is it could probably save a lot on SoC redesign or silicon redesign because you're just reutilizing the existing IP and the capability and you're feeding in an additional pipeline. So it could work. Obviously, there are some limitations to it. So the next step to that is the customers who are looking to design a new system. It could be like, okay, on Gen 1, we were doing just audio. Now I'm going to Gen 2, or I want to introduce a new system, new solution, which always has always on capabilities. How do I want to go about this? And in this also, there are two different categories because one set of customers that we are talking to is saying that, okay, I want to do both maybe vision, audio, ultrasonic type of processing, but I want to keep it somewhat simple. So I just want to have distinct data paths for each particular modality. So maybe I have one data path that does the audio processing, one data path that does the vision processing, and I have separate IPs that are sitting there to handle these particular workloads. It works. It's simple. It's a clean separation and a clean boundary between the IPs. But the problem could come up is that you have possibly an IP that is not being fully utilized, right? Because if you're running a system which is probably focused on the video side, maybe the audio side is in standby or vice versa. And silicon real estate, like real estate in California, is very expensive, right? So if it's not being utilized, the architects and the teams will start questioning, hey, why is this sitting over here idle 50% of the time or 60% of the time? So a majority of our drive of our customers is now saying, I want to have everything running on one IP. So the audio data path, the vision data path, maybe the ultrasonic, always on processing, they still go through one IP. And having optimized IP to be able to process these type of multiple modalities of workloads is very critical. Also, having this supported by a diverse set of libraries, tools, and allowing to consume a variety of these frameworks and networks becomes very critical for success. And then also, within Tensilica itself, many of our IPs are very capable of handling this multimodal processing because always on is a big vector for us, and we are trying to make sure that we're providing the right solution and a very competitive solution for the market to address these type of requirements.
So what are the requirements for these new always-on use cases in particular?
One of the things with this always-on segment is it's unfortunately a somewhat of a new market. So some of the requirements are a bit over the map, but one of the things that we are seeing very commonly is this trend to have both type of processing on one IP. Now, typically, even though customers say that we want to do both vision as well as the speech processing on one IP, it usually still turns out to be they are a little bit dominant one way or another, in the sense that they may be doing audio processing 80% of the time and then speech 20% of the time, or vice versa. And we have IPs that address both those type of requirements. Power numbers are also a little bit interesting, a little bit over the map as well. But one common number that we keep hearing quite often is less than 1 milliwatt for the solution. And this can mean a couple of ways from our conversation. Sometimes the customers are saying, I want to have this always on sub 1 milliwatt solution, either for the entire module, which could be including the image sensor, maybe some low power memory and other IPs as part of the module, or it could be just the IP itself. Can this IP that does always on allow me to stay within my sub 1 milliwatt budget? The requirement for having the sub 1 milliwatt for the entire module is usually a lot more challenging because, as I mentioned, there's various different things that we have usually no control over because we're an IP licensee. So what other blocks the vendor might put, like, for example, in a laptop lid, it probably could have a camera, it could have a microphone, it could have some memory and some other IP blocks. Everything has to fit in less than 1 milliwatt. And then that depends on the technology node, how fast it's supposed to be able to do this always on processing. And then, within that sub 1 milliwatt, what is Tensilica's budget? We have to try to fit within that. And based on the recent engagements, we've actually been able to clear that range quite well. So we're quite proud about that. Area is also very critical. because having a power and energy efficient design is obviously very critical. But if you have a big hunky AI accelerator or a big IP block that gives you that power and energy efficiency, but it occupies like 1 square millimeter to do some very rudimentary type of processing for always on, then it sort of defeats the purpose of what the IP is actually showcasing over here. And last but not least is software and ecosystem support for various different AI frameworks, AI networks, TensorFlow Lite for micro, and things like that is key. Because obviously having good IP without tools or software to run it is kind of pointless. And in fact, if we pull all of these requirements together, it's quite interesting that Tensilica is actually one of the top performers from both power and energy requirements when we compare on the ML Commons Tiny Inference Suite. And we can run all the benchmarks that are required for audio and vision networks out of the box for this always-on processing. And we have a comprehensive software suite with ecosystem support and a very large network of partners that we work with. As a result, makes us very competitive and very promising for these type of engagements with new customers in this always-on space.
Excellent. Well, Amol, I think it's time for your off-the-cuff question. Now, a lot of us can't have our favorite foods these days for one reason or another. So, Amol, if you could have one meal right now, doesn't matter if you need a passport to get there, it's on the other side of the world, what would you have?
So this is a slightly longer answer because fortunately in the Valley, one of the good things to be blessed about it is there's a lot of food options that are available. So most of the things that I'm looking for are usually available. The only problem was during the pandemic, whether we could actually go to restaurants to sit and eat was the problem, and we had to rely more on DoorDash. But if someone were to like hold me to it, I can't get over here in the Valley right now. It's a slightly unique cuisine. It's called Indo-Chinese or Indian Chinese. So it's a fusion of Szechuan Chinese with Indian food. And there is very limited supply of that, unfortunately, in the Valley. A lot more of it back in India, where I'm originally from. And then if you go to the East Coast, maybe New York, New Jersey area, there's a lot of options for those. But that would be probably one of the things that I really, really like.
Sounds fantastic. Well, Amal, I think that's all I have time for today. Thank you so much for joining me.
Amelia, I appreciate it. Thank you very much for the opportunity, and I hope to talk to you again on another fish fry topic.
Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EE Journal. If you're into Twitter, you can monitor our tweets at EE Journal TFM. And don't forget, if you would like to follow my personal Twitter account, check out Amelia D 1978. And hey, if LinkedIn is more your thing, I completely understand. You can follow us or me on LinkedIn as well. And we have a YouTube channel, youtube.com/EE Journal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series, hosted by me, and a variety of fish fry podcasts as well. And you can subscribe to our EE Journal YouTube channel too. Also, by clicking the links below the player on this week's Fish Fryin' page, you can subscribe to this here podcast through Spotify, Podbean, or Apple Podcasts. And remember, if you'd like to further support this podcast, please leave me a review on that podcasting platform of your choice. It really does help. Also, if you'd like any further information about this week's show, just head on over to eejournal.com and look for this week's Fish Fryin' page. Thank you, everyone, for tuning in. If you know of any cool new technology or heck, you just want to chat, shoot me a line at Amelia, that's Amelia, at eejournal.com, or post a comment on our forums on EE Journal. For the week of November 18th, 2022, I'm Amelia Dalton, and you've been fried.